Okay, so of course the main keynote gets obsessed over by a big team of professionals for weeks, but here I get to be a lot rougher and more opinionated and even a little bit critical. I actually wrote up all of my notes on the plane flight over here, which I know drives a lot of production people crazy, but I think that's part of the charm of this. So here we are 4 years on. And I get reminded of this quite a bit when I started at Oculus as a new employee. I did what a good new employee does, and I adopted the company coding style, which was Michael Antonov's, which included headers at the tops of files with creator and date. So now I still run by all of this stuff and see author John Carmack created 4 years ago. Boy, it's been a long time that we've been working on this. And VR hasn't taken over the world yet, but it is showing up in a lot of surprising places. Just last week, I was at the grocery store, and I looked over, and there was a Gear VR on a poster for some immersive wine tasting experience or something, which is a very strange thing that 4 years ago, we probably would not have predicted that we'd be seeing it in those sorts of circumstances. But there still is this sense that maybe this year we are out of the heroic age of VR, about shipping consumer commercial VR out to people, where the people that signed up for this bold new journey to go out and build these products that hadn't been out before. And some people expected it to be magic right off the bat, that it would go out and there would be a bolt of lightning, and there would be this huge amount of success. But the truth is, we're a product competing against hundreds of other very good products and very finely tuned products. And it's going to take a whole lot of work to kind of reach that level of success. But I do think I'm optimistic in so many ways. And much of what makes me optimistic about VR now is that it actually feels like all of the pieces, all of the ingredients that we need are already really here. They're just not stirred, cooked, and seasoned exactly how they need to be. When we look at the fact that we have over 2,000 applications in our store, and there's a broad range of quality, but there are some very good things that almost anybody should be able to find something good and interesting in the store. And I look at and say, Facebook is largely an advertising company. We should be good at connecting people with the content that they're going to enjoy, but that's something that we're not doing a great job at yet. But I think that there's huge room for us to improve that, and there's a lot more that we can do. And the fact that 360 media has probably exploded beyond anything I would have expected 4 years ago. A lot of Facebook having 360 in the feed, both photos and videos, is huge. The fact that we have thousands and thousands of high production quality 360 videos and millions of 360 photos. 360 photos are by far the most popular form of user-generated content for virtual reality or for immersive media. And terminology-wise, I have tried to settle on using immersive media more often, because we can have this whole mess of different content types, whether it's 360 or 180 or stereo, whether it's got 60 frames per second or narrower fields of view. And I lump all of this together and just try to say, immersive media, something that's better than looking at media on a flat screen. And I think that there's enormous value that's already there that we're, again, just doing a poor job of exposing to people. The fact that I make this comment a lot. If you look into Oculus Video and you say, I want to watch 360 videos, you could be forgiven for thinking that there are only 80 videos as you page through sort of the top featured things, not that there are thousands and thousands of them available just kind of waiting to be discovered. So these are some of the things that that Oculus should be doing a better job at. And in our partners, we do have some world-class brands like Netflix and Minecraft that everybody in the world knows that are on our platform. And the web experience that we're providing is getting pretty good. And in many ways, the web is the backstop for all of the apps that you don't have, where there's a web page or an application for practically anything that you could want to do. So again, it feels like the pieces are there. And in many ways, Samsung has done a better job at being user-focused than I feel Oculus has in many ways. When their applications first launched, the original Samsung VR, or Milk VR as it was at the time, or the Samsung browser, I was fairly critical of the initial applications. I would look at them and say, they should be doing this in a time warp layer, this should be filtered better, this wrong option is on here. But they released version after version, and we look over sometime number of versions of later, and Samsung had the #1 application in VR for a while. And I used that to berate a bunch of people in Oculus about, like, we need to step up our game. Samsung is out there listening to users, doing what they want, providing the features that they actually find valuable. While I think Oculus has, in many cases, focused on, we want to build the platform, we want to build the infrastructure for some of these things, but it's easy to kind of fall into a trap there and not judge yourself on value and impact to the users when you're saying, well, I'm building infrastructure that's going to rely on somebody else to extract this value here. So I do push Oculus very much to try and say, well, let's actually do things for our users, not necessarily for our platform. Often I'm like, in the voice of Tron, we should fight for the users. But many of our applications in the store, we've got 2,000 plus applications, but so many of them are stuck on sort of that first version, like the original Samsung applications, and they don't really get to the point of being able to be iterated on and cleaned up and brought to that level of value. And in fact, some developers go through a series of applications. They build a VR application, do something interesting, then they build another VR application and do something interesting, but they're all only taken to that first maybe 80%. Or sometimes, like in game development, you talk about how the second 90% is always the hardest. And not many of our applications are going that extra mile where all the really important magic and user value happens. And there's a school of thought where that could be the intelligent direction, where if you believe that you need a killer app, that it's something nobody's ever seen before, then it can be completely rational to be sort of point sampling the application space, trying lots of different things or throwing things at the wall and seeing what sticks. So if your thought is that nothing that anybody's doing is even on the right path to being the winning solution, then you just try shooting around randomly in different places. But I'd like to present an alternate viewpoint there, where there are a whole lot of nonlinear value thresholds, where it's not a matter of adding a little bit more work here always results in a little bit more user value. Sometimes there are very nonlinear or very sharp cutoff points, where if you look at many of the things about winning and succeeding in lots of different areas. I mean, even the revenue streams at our stores, it hurts to look at these sometimes where you have a handful of applications that go make $1 million here and are very successful, and then you have hundreds of applications where you've had developers put developer years of effort into something and wind up with $500 of revenue from it. And that's really sad, but it's unfortunately, that's reality in almost all of these consumer-facing industries, where sometimes the difference between something that does almost nothing and something that is really huge are relatively minor things. And things like Facebook and Instagram are examples where they had competitors. They had competitors that were doing very similar things. And in many cases, the differences between what became the multi-billion-dollar juggernauts and the companies that went out of business were doing dozens of small things somewhat better. So I would like to push everyone towards trying to work harder on existing applications. And there's another argument for that, in that because each new generation of Samsung devices especially, we bring in huge new tranches of users. And that's an opportunity that an older application, cleaned up, improved, has an opportunity to make brand new, fresh impressions on people. And I'd also say that, again, in terms of application discovery and presentation to users, we're not doing the best possible job, where an application could go out, vanish without a trace beneath the surface, not necessarily because it maybe didn't have a kernel of something right in it, but because it never got exposed to the users right. It needs the different guerrilla marketing tactics, and all the things that people do to be successful on other platforms also have to be applied to the platforms in VR. And so if you have a brilliant idea, if you think you've got that lightning in a bottle, the killer app, by all means, go ahead and work on it. But otherwise, you can always spend time improving the existing applications. And those are good muscles to exercise. So even if it turns out that that wasn't the magic app, going through the disciplined work of making it as good as it can possibly be is what's going to need to be applied when you eventually do get the magical application. And when I complain, kind of bemoan internally about how much better our VR applications could be, about the things that they could be doing better, why the graphics should be better, why the responsiveness should be better, why the load time should be better, I have people that that could know and agree, but they'll say, but all the devs, they don't have your experience. To which I'd reply, well, go get it. Grow stronger. I'll help. There's a lot of people that do have this experience. You can find old timers that know how to do this type of optimization, and even the new people that know how to do this type of user testing or even marketing. These are skills that that are going to be necessary for success. And some people would like to think that this type of disciplined coding and design within very tight constraints, that maybe if, like in the old days, you could just wait a few years and your lazy design whatever just works on the new computers. That was the way of PC development for a very long time. But we're in a situation now with mobile being important and with the end of Moore's Law kind of drawing nigh, that those types of skills are absolutely going to remain important for the foreseeable future. This future device that we all imagine, where we have AR sunglasses that billions of people are wearing, that's probably going to have at least as tight of a power budget and design constraints as you have on Gear VR. It's going to have lighter weight, smaller battery, less thermal mass. It'll be expected to run for 20 hours instead of 3 or 4. You are not going to have some magical thing that comes in between now and then that's going to just solve all of our problems. And this distinction between, I raised the hypothetical question to a lot of people. If you had a choice between getting magic hardware and magic software, which would you choose? If I could say, well, I could take Gear VR or our standalones and automatically give it 4K displays, give it twice the power performance that it's got right now, magical optics that are perfectly crisp across everything, or you could get software that actually does things to the limits of what the hardware we have today can do. And I have always taken the side that right now I would rather have magic software over magic hardware. I think that we have enough extra value that we can put into the software on the platforms we have today to make those kind of critical differences. And I think we could take what would be thousands of dollars of hardware, magically put it down to this low level, and the current software that we have still wouldn't be incredibly awesomely engaging just because some of the hardware magically got a lot better. So I gave a commencement speech earlier this year, and the advice that I gave to the young, impressionable minds there is basically the same advice that I'd give to the older, but hopefully still impressionable minds here. And that's to embrace the grind. Work that you've all shown that you're bold in starting to work on an emerging platform that's not really mainstream yet. But it takes more than just be bold. You have to actually work really hard. And you've got to fill your products with give a damn, to really care about every aspect of them and turn them into the things that you believe in everything, you think you've done the best possible work, because the whole world's first impression of VR is largely ahead of them, and you might be providing it. So every little detail counts. I like to say that success isn't about that one brilliant idea. It's about the doing 500 or 1,000 little things right and getting it all done. So despite my comments about favoring magic software over magic hardware, it's fair to say that the big announcement, a lot of the buzz from yesterday, is around our standalone hardware. And a lot of people have been surprised that I've been the champion of mobile and basically lower-end VR, given my prior history with high-end PC and pushing the kind of the limits on expensive GPUs and so on. But I do think that I signed up for this mission of getting 1 billion people in VR, and that's not going to happen with very expensive hardware. And I'm also not willing to just say, well, let's wait 10 years or 15 years so that the capabilities of the very expensive hardware are now somehow trickled down, if that ever happens. I do make the point that you should believe today that literally the power of the PC will never get to a mobile platform. We'll run out of Moore's Law first. It's just not going to get there. We'll get another order of magnitude faster, but we are unlikely to get 2. So if we want to get to this massive scale, it does mean adopting these lower power, lower end mobile technologies. And I like Go a lot. I've been using it Normally I spend most of my time actually programming, but in recent weeks I've been spending a lot of my time being probably most valuable beta tester or dog fooder on Go. And I've been trying to take it to the places in my life where I would normally use my iPad. Instead, I'm carrying around my Go, in a little bag for secrecy reasons up until now. Now I can start actually carrying it openly. But this is the place where I feel standalone will fill. It's not your phone, it's not your work computer, but it's the place that a tablet could fill. And I would take it around, I would use it in my, I'd do my morning trawl of Twitter and Hacker News inside the browser in Oculus, inside the Go. I'd watch Netflix with it, I'd watch movies in it. And in fact, one day, as an example of the different use cases, I basically left it in Netflix, and it sort of functioned as a Netflix machine. The headset was sitting there. I could put it on, watch for 15 minutes, take it off, go do something else. A few hours later, put it back on, watch a little bit more. And that's a very different user experience than working with Gear VR. It's the same software there, but instead of going through the trouble of starting it up, docking it, launching an application, getting through that, friction matters a lot. And I preach this in all sorts of application areas where 1 click versus 2 clicks versus 3 clicks make enormous differences. And people that are hyper analytic about things like website conversion rates and things know the value of a lot of these things, about how long it takes you, how many actions it takes you. And the standalone that can sit there as a device that really is just ready when you put it on, that is a significant change in the experience, even if you do basically the same things. So I'm pretty bullish about the possibilities there. One of the things in me trying to, again, treat this like I would one of the other devices, I left it on my nightstand, and in the morning I'm like, okay, pre-dawn time, let's put on the headset. And of course I was like, too bright, blinding in the morning. So that's when you can think about, well, should we have something like an automatic proximity or sensor for ambient light so you could adjust for that kind of condition? But it's interesting that it does show up some of the trades that were made with Go, where because it's an LCD screen, even when the screen went completely to black on my dark adjusted eyes, I was like, this is still pretty bright. And there's several points about Go where they are net wins, but not pure wins, where there are some trade-offs that were involved. And of course, the biggest trade-offs were, I think the price point is magically important. When I talk about nonlinear thresholds, getting to $199, I think is incredibly important. There's a lot of data from things like console sales, where maybe you start at $400 and you sell this much and you drop to $300, but dropping to $199 is one of those threshold points where you do a whole lot better at that number. And it's also a number that psychologically for a lot of the well-off people, it's at the point where it's a giftable price point also, where, lots of us in VR do not want to buy a gamer PC for our parents or aunts or uncles or something, or if they're not using a Samsung phone, we don't want to set up a whole separate phone for them to set up a Gear VR. But when you've got the standalone that's just, here's this box, you don't need anything else, open it up, get through it, and you'll be in VR, and you can look at these applications, I think that's really important. But some of the trades that happened, obviously the LCD screen versus an OLED is a big one, where we've spent years talking about all the virtues of OLED displays. Rift is OLED, Gear VR is OLED. And there's some powerful value to OLED. The fact that you get perfect blacks and you get very pure colors, you have very quick response times to it. And these are things that are valuable for VR. But it's worth noting that there are some significant trade-offs to OLED as well. The Rift in particular spends a decent amount of computational time doing mirror correction to correct for the inconsistencies across the individual OLED pixels. And to do that involves generally adding some values to some things which can detract from the pure black argument. And on the Samsung Gear VR in particular, for years I've struggled with the problems with the deep blacks. Anybody that watches movies in the theater or in Netflix, when scenes go very dark, they just don't look that good. And it took me, I only just this year figured out the last piece of that puzzle for why some of those things are. For a long time, we've had the obvious case of there's the two-frame rise ghosting problem. If you have a very dark line next to a bright area, you move back and forth, you will see one distinct frame of a slightly dimmed ghost version, and that happens with the very dark values not able to rise completely to the very brightest values. Again, on PC, where we have lots of performance, Rift does a software overdrive to try to deal with that. It can't handle everything for full black to white transitions, but if you're going black to gray for the next frame, it can boost the gray up a little bit higher and does a pretty good job of working that out. But again, it takes processing power. The other problem is what I've called the black smear problem, where if you have some very dark imagery there and you move side to side, it has more persistence and smears across the screen. And I spent at least 3 times I tried to fix this problem in Oculus Video by adding dithering I would put it directly into the time warp layer, reading the movie file directly and the scene file or the scene images, and I'd add noise. I'd add temporal and spatial dithering, and it never really worked right. And I was very disappointed with this, and I never quite understood until just this year. I was doing some comparisons of the video screens and trying to, again, get to the bottom of some of these problems. So I went into a completely dark broom closet, all the light blocked out, and I had my Samsung phone down there with a color pattern grid in low persistence mode going from 0 to 255, stare at it until I could carefully look at everything, and then it was clear that many of the low-order values, instead of being a smoothly increasing color gamma ramp, there are flat spots into it. So there are several areas where it's like 0, 0, 0, and then it bumps up to some non-zero value. And this is why when I'm trying to dither, going plus or minus 1 value there, none of that wound up helping because it was all inside this flat spot. So that's something that I think Samsung could probably fix. I suspect that the way that comes about is you run the proper sRGB gamma curve and say the colors need to come down to here, and you've got different responses for red, green, and blue. So it's mathematically the closest, but what I would argue for is that we should have an always increasing color ramp, even if it meant that the colors weren't as pure and you maybe had hue shifts down at the bottom level. So I think that that's potentially fixable. But in contrast, on the Oculus Go screen, it's an LCD, but all 256 color values are discrete there. I can look at that in my dark broom closet and see that each of these does have an improvement. So the dark black areas that did tend to look actually bad on the OLED screens look better here. It has more subpixels, where something else that's kind of an open secret is that the pentile arrangement that a lot of OLED displays especially use is basically a cheat on resolution. Instead of having red, green, and blue for every pixel in a 2560 by 1440 display, you'll have 1 green for every pixel, but only 1 red and blue for every other pixel. And in fact, there are pentile schemes from some other manufacturers that have even less subpixels, where you have 2 subpixels out of 3 on Samsung. There are some that only have 1.5 out of 3. So this is a difference where the Go screen is full RGB stripes. So it's got 3 subpixels. So there's more actual resolution there. It fills out the space better, so the screen door effect is reduced. You wind up getting some wins there. So overall, I'd say on net, the screen is a positive. A little more resolution, a little less screen door effect, no deep black problems, but it does have the lower contrast that you'd expect out of an LCD. You notice it especially when the entire theater dims down to that dark area. You can still see this kind of gray backlight area, like you're looking at an LCD TV in a dark room. But still, I call it a net win. The other disadvantage of the LCD is that it does hurt latency a little bit. The way the OLEDs work is we do a rolling shutter, we chase the raster. It's lighting up the screen for a little bit, and we are drawing basically as close as we can within scheduling limits behind it. And that's how we get to this super, super low latency on the Gear VR. Now, with the LCDs, the OLEDs change in microsecond or so. They are just super fast. You command that pixel and it lights up or shuts off. But LCDs, the way they work, you say, I'm changing your value, and they take a while to change. Older LCDs could take 20 milliseconds in some cases. Many desktop LCDs, you can see a 2-frame ghost just when you're moving your windows around. The better LCDs now can change in 4 or 5 milliseconds. But still, that means what we have to do is change all of the values with the screen backlight turned off, wait a little while, and then you blast the backlight and everything comes on. So that is a global shutter effect, which is the way Rift runs in most cases. And internally, this used to be one of our great technical debates about whether what artifacts rolling shutter would have versus global shutter. And many people argued that this was just not going to work out well on Gear VR. But now pretty much everyone agrees that it's an OK compromise. You get less latency. There are absolutely some artifacts that we don't fix with rolling shutter, but they're things that in practice don't really matter. Time warp does an interpolation between the top and bottom across time, as well as what your orientation changes are. But if you have something like a long, like in Gear VR, if you had a bar in front of you that was moving up and down rapidly, because it's a rolling shutter, the bar would feel like it's tilted a little bit. If you were moving your head up, the entire viewpoint up and down, time warp could fix all that up by moving the entire thing. But if an animation of something moving up and down in front of you would not be corrected correctly. But it turns out that just doesn't happen all that often, and the latency advantage of rolling shutter is a big deal. So when we don't have rolling shutter on the LCD, it means that we've lost some responsiveness, and we should fight really hard to find a couple more milliseconds here and there. We can tighten up the scheduling. We may be able to do some kind of late latching, even for attitude, to carve a little bit off on the final GPU time warp. But it's still unquestionably a few milliseconds slower than Gear VR. It's still very good, and we're hoping to make it a little bit better, but it will probably always be a little bit more latent than Gear VR. But again, on net, I think it's a good win. The lenses, the optics in Go are second-generation Fresnels, or they might be later gen, but they're newer Fresnels from our research team's development work. I always thought that Rift, the Fresnel trades on Rift were pretty serious. I was pretty put off by the glare effects that happen in Rift when you see all of our early demos. We'd get the nice, bright Unreal Engine 4 logo popping up there, and you'd see these fringes coming off in all the different directions. And we have design. That's one of the things, like in Gear VR, one of the design rules you should follow is don't put bright whites in the corners because of flicker sensitivity. On Rift, you should never have bright whites across a black background, not because of flicker, but because of the Fresnel glares. But it does help a lot in other areas. The biggest win for me in the optics is that Gear VR is really only clear right in the center. And if you've got things further away, it's just blurry, almost no matter which way you adjust the focus wheel. And this shows up most in games that have face-locked like HUDs. In Minecraft or Drop Dead, things like that, where you might have information presented around your periphery. I found that strikingly better on the Go optics than on Gear VR. And in fact, it's encouraged me to go back and say, now that we can actually clearly see more of this, I'm readdressing some of my trade-offs around chromatic aberration correction, where in the last couple years, while we shipped initially on Note 4, we had chromatic aberration correction on like the movie screens. We turned it off on some later versions because we were having performance problems on some driver versions. And part of my argument was it's a blurry mess away from the center anyways. The fact that we have chromatic aberration is not the worst thing there. But now that I'm spending so much more time in Go, one of the things that I did last week was re-enable chromatic aberration on movie screens and some really picky fix-ups for things that have to happen. If you're just doing a normal game rendering, you render the 3D world, you might have screens or different things in it, you just turn on chromatic aberration correction and everything works. But if you're using layers, time warp layers specifically to get the high-quality movie screen or the high-quality panel, there are some surprising subtleties to that, where turning on chromatic aberration correction can actually give you more artifacts in some ways. Where this was visible in, you would see blue fringes at the edges of the movies in many cases. And you could carefully blend over it, and they just wouldn't go away. And there's two interlocked reasons why why that happens. One is that when we do chromatic aberration correction, blending layers, we have one alpha channel sample that blends this, but we've spread the 3 chroma channels apart. Again, Rift, with lots of computing power at its disposal, does the compositing of layers properly, where every channel gets its own alpha value. This is, again, a case where you do all of these things that Rift does with mirror correction and overdrive and proper blending. Just running in an asynchronous space warp, just running the compositor on from Rift would take up all of the computing power on a GPU on a mobile system, leaving absolutely nothing for your application. So we have to live with these trade-offs. But it's possible to fix a lot of these with design issues. So avoiding the blending problem was a matter of, I used to have a vignette around the screens to nicely fade off the screen. So turn that into a hard edge truncated cut. But then you get visible stair-step edges in some cases, and you still have fringes. And this was one of the other unexpected aspects of it. If you've got a rectangle, a screen in space, and it's clipped from the texture coordinates 0 to 1, and you do chromatic aberration correction, what that does is the pixels up in the corner, red spreads out towards the edge, blue spreads out inward. The problem is that red spreads off past the edge of your layer, and that red never gets drawn anywhere, so you're left with only the blue and greens there, which winds up color tinting everything around that. And the solution is to make sure that if you've got a layer that's going to be hard clipped, you need to make sure that any colors that are going to be in there will be inset, say 16 pixels or so that there's room for the reds in the corners to spread out. And this works fine in the cinema, where it's okay to have a little bit of a black border around things, but it can have some trade-offs trying to do it in other panel applications and so on. But still, the net win for the Fresnel lenses. I really love the built-in audio on Go. This is something that it pains me with Gear VR when we try to tell people do good audio, but the truth is most of the people most of the time using Gear VR are just hearing the phone speaker, little monoscopic speaker up here, because it's just a hassle to arrange to dock the gear, plug in your headphones, hope that plugging in the headphone doesn't actually undock the Gear VR if you press too hard, put this on, then put the headphones over and worry about tangling up cords. Somebody that's going to sit down and watch a long show or something, it can still be worthwhile, but it's a huge amount of this friction that I keep talking about getting people into the experiences. And while Rift has built-in audio, I've always felt the little flip-down headphones were fairly awkward for me. It's been a little bit of friction on donning the headset and getting it down, getting it adjusted. So the way the Go audio works is the drivers are inside the main headset, but it basically pipes the audio through the first part of the straps. And an audiophile will probably have some complaints about this and say it doesn't have the best frequency transmission for whatever range, blah, blah, blah. But it really is the optimal for a convenience standpoint. You put it on, spatial audio works, you can look around and hear things spatialized. It puts a lot more value onto doing that. So I count that one as a pure win. You can still connect other headphones to it if you want a perfect over-ear experience, but for 99% of the times people are going to use it, it's a big win. Now, the great thing about having our own standalone headset is that we can address things top to bottom, that it's no longer the barrier between all the different players, where what Samsung's going to do, what Oculus is going to do, what the carriers will allow Samsung to do. So that is one point that wasn't made completely obvious, but this does not have cellular service. And that's one of those really tough decisions that you have to make on a product level, where on the one hand, cellular stores are incredibly enticing, thousands of stores all over the place where if you get your product in there and they push it, they're behind it, you can sell a whole lot of units. But it's usually tied into cell phone contracts and having data plans and all the things there. But the worst part is that you lose control over being able to just completely dictate the user experience. And this has been one part of the enormous set of problems that we have with updates through Samsung. There are so many players involved with this in doing updates. I know Gear VR is a nightmare for system updates. I have this where at my house I've got an older S7 that I occasionally use for playing Gear VR Minecraft at home. But if I haven't used it in 2 weeks, I can practically guarantee that I'm going to turn it on, and there's going to be some combination of an Android update or a Samsung update or an Oculus update. And you know the drill about you turn it on, it maybe updates this and reboots. You try to dock it, Samsung needs to do an update to something. You start up, and Horizon is downloading something else. And it's a terrible user experience. And this is something that we want to have high priority on making a lot better. We are hoping the product is designed around if you turn it off every time after you use it, you're still going to have some update problems. You won't get the updates, but I'm arguing for we should never, ever update something while the user is in VR. And if somebody did turn it off every time after they used it, they would never be blocked. They would just keep using the experience they've got. That may not hold through all the way to the end because it gets really tempting when you're maintaining backwards compatibility with things to say roadblock everyone, force them to update. But some of the worst things will get much, much better. Like the problems with driver updates, GPU driver updates. This has been a nightmare. The problem is that we go and we work with Qualcomm and ARM, and we get these extensions built in, but we can't even first get them onto the Samsung headsets. Because Samsung has a whole process they don't take things raw from the vendors. They evaluate each thing and apply different patch sets and so on. And then they don't even go out to their internal builds for quite some time. And then the big problem is that Samsung doesn't even have the power to make these things happen to the users, because when they send out a maintenance release, when they can say, all right, we've updated our kernel, our drivers, all of these important things, or we've got a new OS version, it's still up to Verizon or AT&T or whoever to decide when their customers are actually going to get that over-the-air update. This is going to be one of the powers that is going to be very good for us in the standalone space, where we could decide at any given week to say we're going to replace the kernel or the driver or any of these things. And this should allow extensions and advancements to happen a lot more frequently. And I hope to use this many cases to improve the Gear VR experience, where we can have arguments with Samsung about whether something is a good idea or a bad idea. And I absolutely know our place with Samsung, where Samsung is about selling hundreds of millions of phones, and VR is a small fraction of their business. It's a huge part of what we're doing, but they are perfectly justified in being conservative, not wanting to necessarily jump on things, and to let their most important businesses kind of drive their decisions. But if we can say, we think this is a good idea, look, we already did it, here's the code, here's where you need to patch Android, I think we've got some chances of getting some more improvements more rapidly into some of the Gear VR side of things. This is the multi-view debacle, the way I look at this, where I've been talking about multi-view for at least 3 years here. And yes, it is there finally. It seems to be reliable in the S8s. It's providing excellent performance wins for many applications. But wow, that took a long time. That was very surprising. When the world that I came from, I had such good relationships with NVIDIA and AMD on the PC space. We would do things like say, all right, this is a good idea, let's go do this. And there could be an experimental extension turned around in a week, and we could have things out to users sometimes in just a couple months. Seeing this go all the way to 3 years and still not across all of the devices, probably never will show up on some of the earlier ones, was a very eye-opening experience. And there's an aspect of that that's fed into some of the other strategic things, where some of the problems with the way multi-view was set up, there were some tactical mistakes made in the actual specification that I wish we could go back and change that would have made things easier. But it relied on getting into devices and then getting into game engines and then finally actually getting taken advantage of by new applications. We're working closely with Qualcomm on a foveated rendering extension, which by strategic design is trying to bypass all of those things that made multi-view very painful to develop. It's trying to be set up in a way that we can enable it almost transparently to an application. In general, I'm never in favor of doing things completely behind an application's back, but if we can make it just a matter of turn on a flag in your manifest and we will enable foveated rendering. That's a far different thing from upgrade to the latest version of Unity, change your code to behave this way, rebuild everything, and then it will start working. So there are approaches that we can take that this has been a real change in my viewpoint, where 5 years ago, as low-level PC developer, I was deeply suspicious of any time drivers had to go do magical things, because it was almost always not what I wanted. I was like, let me do the specific low-level things. I know what I'm doing. I'll take care of it. You're going to make decisions that are not going to be optimal for me in various ways. But this 3-year odyssey with multi-view has changed my risk profile for that, where I'm like, okay, yes, the vendors very likely can still make terrible mistakes in the drivers in different ways, but it's still likely to be higher user value if they can make this change, and we can make 500 applications automatically somewhat better, a little bit higher performance in the middle or a little bit better frame rate by using something like that. But for any type of extension, because we own the whole platform now, we're going to be able to roll out fixes and changes and experiments much more quickly. And so that's very exciting. Now, Go is still an Android device. It's Gear VR compatible. I would expect everybody, I would not encourage anyone to develop anything Go exclusive. You should still be considering Gear VR the primary platform on mobile. It will be quite some time before standalone reaches the numbers that mobile has. And this is a point of strategic contention inside the company, but I'm of the belief that mobile drop-in cell phone-based VR is going to be persistent. There are many people that think that things like standalone will take over and will become the dominant form. But I think it's likely that even if we look 4 or 5 years into the future, that mobile cell phone-based VR will still probably have the largest number of users. I think that, again, our software is not great now. As we make our software much better, even the same type of platform will get to be a better, more valuable experience for users. And what constitutes our minimum bar of this kind of Note 4 level of performance, we're going to be seeing that in $50 phones in future years. And I think that there are massive markets where a cheap phone playing VR applications will still have significant value to users as our software ecosystem gets better and better. So Go should not be looked at as a completely separate thing. It really is. Our branding and marketing on this is going to be pretty weird, because internally I can say, well, it's kind of a standalone Gear VR, but Gear VR is Samsung, Go is Oculus. It's a different thing. It's our mobile VR platform, and we need to figure out kind of better messaging about that. But in talking to developers, you should still certainly think about it as one target platform. In many ways, Go is going to be an excellent tool for developers. Because we have this lower level control, we are much less likely to break things that are important for developers, like the various profiling tools or the debugging tools. We've gone through so many generations with Samsung where, well, this tool worked this generation, but on this next rev it's broken again, or it finally works over here. Please don't upgrade anything and potentially break it in the future. We can be a lot better about that. We'll still make mistakes, but because we can actually fix them the next week if we need to. It's going to be important for developers. Now, it's interesting when we consider what the actual use cases for it, where on the one hand, you might think this would be a perfect target. We'll have better control over different things. But because it is an all-in-one headset, I find myself, I set it face down on the table next to me, so I spend a lot of time kind of sticking my face down into the headset to quickly check something, as opposed to the mobile stuff where everybody has their little phone holders where you've just got phones stuck up sitting in front of your workstation when you're working on regular Gear VR things. So there's still a good argument for testing on. Certainly you need to test on multiple platforms, but as development tools, they'll have different values in different places. Then on the high end, again, I'm most excited about Go because it's near term. It's coming quickly. Developers, you'll all be seeing them like next month or something, and then early next year, available to users. But the high-tech side of things with the Santa Cruz prototype direction is, of course, exciting for people that are interested in where the bigger technology bets go. And again, in terms of strategic disagreements or arguments inside, there's a legitimate argument about What is the place of 3-degree of freedom tracking, basically the Gear VR and Go level of things? What experiences and things can people do there versus do we need to have 6-degree of freedom tracking to deliver reasonable value, and then do we need controllers to deliver value? So Santa Cruz is making the bet that it's all the way to Rift spec, essentially, where it's 6-degree of freedom position tracked, dual 6-degree of freedom touch controllers. Go is a couple steps backwards, where it's a 3-degree of freedom controller and a 3-degree of freedom tracked headset. I still pretty firmly believe that there's a lot of value we can deliver at the low end. And this will be one of those things that if we do everything right on Go and it goes out and it doesn't get much traction, then we'll have learned something and we will have pivoted permanently probably to the higher end. But I suspect it's going to do pretty well. Realistically, of course, I don't expect Go to go out and do Samsung-type numbers because Samsung is a juggernaut on all of the kind of marketing and sales and the things that they do. It's been amazing to see the things like I was in London seeing the building covered with Gear VR and Gear 360 advertisements, and don't expect that from Oculus in the coming year. That level of presence is really a Samsung superpower. But the 6-degree freedom tracking side of things, the argument that I always make is that a lot of what people do in Gear VR especially wouldn't even benefit from 6-degree of freedom tracking, where the video applications, the 360 videos, 360 photos, even watching things in Netflix or the cinema theater, benefit very little or not at all from 6-degree of freedom tracking. And it is true that this is where people are spending their time. The arguments that we go around in circles with are saying that, I keep saying I made the prediction early on that more than half the time is going to be in these media applications, and it absolutely is. The counter argument is that, well, that's because our games aren't very immersive, that they don't have the real present sense of VR. You need hands to be able to do something in VR, otherwise you're a passive spectator. It's not surprising that there aren't really involving activities there. And it's a credible argument. We have reasonable people can differ on some of these things, and ultimately the market will have out. Will be informed by how people respond to the product. But I think that there's still quite a bit of value there. But still, there's amazing things to be had by getting the full 6-degree of freedom tracking in a mobile space. Everybody talks about room scale VR, but the ability to walk around a large space and have stadium scale, arena scale, or world scale VR, where you can move around and walk behind things rather than navigate behind things. This is, of course, the core magic of VR. This is the really powerful stuff that VR can bring. And it is inevitable that all of this will come down to very low price points in mobile. There are still enough trends on things that, quality of cameras and integration of different things, that these prices are going to be dropping. It is a question of where mass adoption happens, though, and at what price points. I do harp again on, I think $199 is a superpower for Go, and it's unlikely that we can throw all the other things in at once. But when you take that, everybody that's seen the demo that's playing Dead and Buried, and I do agree that it's possible to take the magical essence of anything anybody's doing on the Rift and the PC and bring that to a mobile form factor, but it is not going to be easy. I make the comment a lot about how a high-end PC might be burning 400 watts of power, and on a mobile system, maybe you're burning 4, if that, in a lot of cases. So a factor of 100 in power difference. It can be bridged, and if you look at, again, Dead and Buried is done by crack internal developers. Andrew and Ryan, the Oculus Strike team people, they know what they're doing. They're veterans. They've been around for a long time, and they bring over the entire essence of what they were doing. You're missing a lot of subtleties in some of the graphics, different aspects, but you can get the core magic. And it's possible, but it is a lot of work. And again, like my talk at the beginning, it takes people buying into some of these skill sets that are not necessarily being exercised very much right now. If you're interested in seeing that level of interactivity and performance, you might as well start by sprucing up some Gear VR level things, because that's performance, relative performance levels that you have to deal with. Some of the things that are interesting from the standalone engineering side of things. I've often commented that mobile performance, you only get kind of half or less of what you think that you would get, and largely that's because of thermal limits, and everybody's had the issues of Gear VR overheating. And I stress about this a lot, where everybody, each time we get a new generation, like the S8 is a lot better. And people say, well, we want to do more aggressive graphics. And I'm always like, can we just hold back and instead have a device that never overheats? It's a balance between saying, well, I really want to add my specular highlights to this. And I'm like, well, I really don't want to overheat and have a user say, well, my device just kind of crapped out on me. This is not very good. But with proper cooling, it is possible to run the devices at their maximum or very high clock rates. But that's one of those engineering changes. Do we put on active cooling and have fans blowing over this? And certainly we're going to have lots of this computer vision work going on to track the world, to track the controllers that comes out of the minimal hardware that's going to be there and driven by the battery. So there's a lot of trades there. Some of the other interesting aspects of owning it, like a discussion that came up, one of the problems that we have on Gear VR is lens fogging. One of the reasons why it's less of a problem on Rift is you'll notice that the Rift stays kind of warm. If it just sits on your desk there, it's burning power. It's probably burning as much power as an active cell phone when it's sitting there idle for the cameras and the Rift itself. But that actually keeps the lenses from being as much of a fogging problem, because the temperature of the lenses determines when humidity or sweat condensation will wind up landing on the lenses. That's something we've talked about for Go, where maybe we should, if you've got it plugged in, if you have it on the charger and plugged in, we should drive the screen, turn the screen backlight on, but leave the pixels all black, so it generates heat into the device and notably keeps the LCDs warm, so they're going to change faster. We have concerns about various low temperature conditions for the LCDs as another trade-off against OLEDs. One of the other great things is having our own operating system team that we can now track everything down. Like, it's been so wonderful for me to be able to say, like on a Samsung phone, you do a systrace, you get a list of everything that's going on, and I just stare at it dumbfounded, like, what is all of this crap running on my phone when I'm supposed to just be in VR? And it's things, like, why is Amazon Videos doing something in the background when I've never downloaded it, but it's a carrier preload for something? And all of that's gone on Go. I mean, on Go, you get a nice list of here's all the processes. They're all Oculus processes from a few basic Android processes. And that's really great. And now to get some of the really great kind of kernel ninja types inside Oculus, being able to track down, well, why exactly is this interrupt blocking this other thing, and we're being schedule delayed for various reasons. So that's been really good. So back onto the Magic Software side of things, my big win for this last year has been VR Shell. And it's something that we haven't talked really explicitly about a lot. We just kind of rolled out, hey, there's changes in all of our first-party apps. But a bunch of the people that hung around with me after hours last OC3 got to see sort of the preliminary version of that, where for years I'd just been saying I was so frustrated how so many of the applications just looked terrible, and I had this litany about nobody, not even Oculus first party, was doing like a good job presenting text in VR. I mean, it pained me deeply how Home was an aliased mess of unreadable text when you start it up. I can't just point at our own applications and say, do it like we do this. Everybody would say, well, this is what VR looks like. They would get baselined by they put it on, they look at Home, and the environment's aliasing, the text is hard to read, all these problems. And I think that that hurt people's expectations, and then people wouldn't even strive for better because they figured, well, Oculus is probably doing everything right. If I look like that, I'm probably doing everything right. But Oculus was not doing everything right. And I had laid out the plan for years. I would say you always have MSAA on. You always want to have blended edges on text. You never want to do a hard discard there. You want to use sRGB. You want to use a custom time warp layer and have the resolutions carefully matched. And if people followed like the app critiques that I would write up, I would say this for years, over and over, about here's the steps to go make VR look good, but very few people would actually follow them. So last year I was showing people just this little demo that I had where I took the top 99 applications in the stores, like 99 random applications, and I had a perfectly pre-filtered environment map, and I used a cylindrical time warp layer, which was the one new bit of magic that happened about that time last year, where previously we had environment maps, we had flat planes for movie screens, but the addition of cylindrical layers was a surprising goodness, where the lenses have a distortion where you have less detail on the sides, but curving around you, not only does it feel nice for VR, but it almost magically corrects for the distortion of the lenses and makes for an even pixel density. So I was using that new bit of technology and then just doing all the things that I had already been doing before. And it looked magnificent. It looked so much better than what we had. And so internally, we always had this long battle between doing things like in Unity, and Unity is a wonderful place for doing game engines, but I've always said Unity is not the most appropriate tool for doing a media browsing system, whether it's for videos or applications or whatever. And what I pitched was a new environment that I was calling VR Shell, where it would handle two-dimensional user interfaces and minimal 3D and environment things. It would be focused on the user interface side of things. And a point that I would make was that two-dimensional user interfaces are unreasonably effective. Everybody's surprised that they think, well, we have to be pulling things in and out, we have to spin things away and do crazy tilty 3D things. And almost all of those turn out to actually be negative for the user value experience, about being able to find what you're looking for and be sold on the value of what you're looking at. So I was proposing we push it all to basic 2D interfaces, basic 3D environments, but we have them all done right. We guaranteed that the pixels are going to come out as good as we know how to do it there. We're going to efficiently handle the loading of the environment assets. And then because it's going to be an a system here, we'll be able to switch between applications seamlessly. No fade to black, load up another application, but instead, you want to go to video, it's here. You want to go to browser, it's here. You want to go to Facebook, it's here. And then we start delivering synergies there, where you can be in Facebook, you can click on a link, it goes to browser, you can download a video, it goes to video, using kind of our optimal presentation tools for all of this. And this was there was a lot of kind of institutional resistance to changing what we're doing, the way we're building our applications. And I cheer that this really was, I think, my big win for the last year, getting our applications migrated over to this new platform. And I think that this is where a lot of our future value rests. Not only does it look much better, but we are pulling in these synergies. And the one thing that hasn't made it in yet, that is our big focus for the rest of the year and towards Go launch, is that Shell was always pitched to be a social substrate, where we've seen enough experiments now where different applications get built for, we have spaces, and we have all the other places that other companies have made social applications. And there's a trajectory that all of these things have, where you build a social space, you've got a chat room, you have a couple of things you want to do there, but then everybody wants to make it expandable. You add a plug-in architecture, you add some way to start doing other things. And I contend that that's backwards, that instead of building a social place and then hacking applications on top of it, I have proposed with this that we build an application infrastructure that has social built in. And there's going to be trade-offs involved. It's not going to have every nifty little social feature that the dedicated social apps have. But my bet, the play that we're making here, is that having good enough social that's always there, that can be a simple click away, not an app launch and browsing and doing all the other multiple steps. Again, that friction funnel that keeps people from doing things. This is core behind what we're doing with venues. There's still a directional bet that we're making here, where we're starting off with venues being stranger-focused for large events, because there's still the shallowness of the friend graph. It's hard to find people that have 2 or 3 friends at the same time that want to go do something. But fundamentally, it's not venues as this separate product. And internally, I've had this whole problem with how we look at it internally and position it externally, where it's not much of a product itself. It's really just enabling the shell core in VR, the social core in VR Shell. And Venues is going to be a trivial video playing app, essentially, that works with this. But eventually, all of that stuff should be available everywhere. And people will say, well, what's the point of letting 10 people join you while you're looking at your home screen? And there's probably plenty of things that don't make sense, but even like browsing through the store, being able to have somebody sitting next to you, watching you page through the stuff in the store and pointing out different things, I do think that there's some value there. Shell is a multitasking environment. When you pop up the keyboard for typing in a URL or doing a search in home, that's a separate, we call them panel applications. We talked at the beginning, we started off making home actually 3 separate applications. We were going to have social and store and recents, or different things like that. Turned out we didn't do that, and the landing page is one big application, so it has the freedom to rearrange things in different ways. But you do have the ability to do that, and we're rolling out a new interface that's going to sit that's going to sit below a lot of the applications to provide common things that everybody wishes we had, like easy ability to see the time, see the battery level. We're going to have a universal bed mode in Shell where you can just pull any of the UI, so you can lay down and browse the web or Facebook on the ceiling while the environment around you still stays properly referenced without going to a void theater system. So I think a lot of these things are going to be very powerful. There's still a few pieces, like I wince every time now that I see the old pieces of system activities when you have the quit to home or return to application mode, which is still not in layers, blurry, low resolution. All of those things are going to eventually be part of the home VR Shell system that all applications will be able to take advantage of. Now, the actual programming model for the Shell applications, this does mark the second time now where I've kind of failed to bring in a radical change in program development. The first one was with the VR Shell stuff that I was talking about 2 years ago, and that I thought it was a pretty powerful and compelling, like the demonstration, the live coding that I did here. But internally, the general thought was, well, nobody really is going to want to use Lisp or Scheme, the racket system that I used, so it should be JavaScript. And we start hacking together a JavaScript version of that Michael Antonov did a lot of work on. But then it's like, well, if it's JavaScript, then it should really just be WebVR. And we spin up the WebVR team, start working on all of that. But my hope of 2 years ago, being able to have this super simple, easy to distribute, simple VR application model, we've lost that. And I have a guarded kind of relationship with WebVR, where in general, it's never wise to bet against the web and the open standards. I think that we should support it as well as reasonably, but we have some passionate WebVR advocates internally, and I'm always trying to steer them. It's like, no, let's build better stuff in VR Shell rather than spending a lot more time on WebVR. There's reasonable arguments. Reasonable people can differ on the priorities there, but I want to make my play on let's do the best thing the hardware is capable of on our systems in VR Shell, rather than spending lots of time on WebVR stuff, which has to work on various lowest common denominator systems. But then the second one, when I started on the VR Shell system, it's one core application, but it loads and communicates with each of these separate panel applications. The first thing that I was trying to do was set up, well, what is the simplest, fastest sort of application loading switching system I could do? And I'm like, well, all right, I'll spin up these services, and then I will literally DL open and load shared object files. And I could set things up so I commented it's like virtual reality like it would be in the 1990s, where you've just got you've got your C++, POSIX, OpenGL, OpenSL, and you write these simple things, and it's one simple little make file. And it had these half-second turnarounds. Applications could launch and show their first frame in 50 milliseconds. And for the low-level developer like me, I loved this. I thought this was amazing. Instead of a whole directory full of stuff to build your project, you could have Hello World look like one file, one C++ file, one make file. And some of the simple applications that I did had these magical response rates, all these high qualities. But it didn't even last a couple months before people are saying, well, we need to load Java code. We need to load all of this stuff that our applications depend on. We need all of these other libraries. And it very quickly slid into panel applications are now full Android APKs, which makes me sad. They've got the whole Gradle to build, and takes longer to start up, and people do take the opportunity to pile in lots of Java, JavaScript interpreters, and all these different things. But it's probably the right thing. It's more important for people that have large, extensive, powerful code bases to be able to easily retask them for this than to be able to build these brand new from scratch, super efficient diamond jewels. So where we are right now is what a panel app is an Android service that an APK provides. VR Shell launches it. You can give it a surface to draw onto, which we can take care of positioning in 3D, and there's a command channel to do things like changing the environment behind you, loading up different models, playing videos, all sorts of different things like that. And so I hope that type of annotation, this is one of my other kind of uneasy relationships with web VR, is I think that there's this great possibility of doing super trivial website annotations where instead of adding a big thing, if you want to add a little bit of flavor in the browser, we should be able to drop in one line into an HTML file, which is basically, send this environment command to VR Shell. So everything else ignores it, but if you're browsing in VR Shell and you go to this page, it changes the environment around you. I think that there's some great low-hanging fruit that, again, the friction funnel, if all it takes to make your website a little bit more VR spiffy is put one line into your HTML file and point it at a 360 photo somewhere, I think that's the type of thing tens of thousands of web pages could reasonably do. If it's a matter of rethinking it for some virtual reality experience and writing a mini game engine in web VR, that's something that I don't think many websites will actually go out of their way to do. So I consider VR Shell so far a pretty big success for us. We have lots of work going on to develop it. The intention is to become this next computing platform that you can do everything that you would do in a traditional computing environment in VR with high quality, with good responsiveness. And there's lots of active effort going on with that. So going forward, if that was my win for last year, my goal for this coming year, really the second half, is to make a similar step in the quality of our immersive video. The power of a really good 360 video in stereo 60 frames per second, high resolution, is really high. And we really lost something even from the very earliest Gear VR Innovator Edition. One of the things that I was so happy about there was that we had the little pack-in SD card that had 16 gigs of media on it, including some high-quality 360 videos. And you looked at those, and that was many people's first impression, and it's a wow when you see something really great. In contrast, now, if you start up Gear VR, you go to Oculus Video, and you watch some 360 videos, it's just not that great for a lot of different reasons. And I think it's fixable. I mean, I think we can make what I hand-wavingly call about a factor of 2 improvement in the quality of what most people see when you just go through that process. You go through and say, I want to go watch a 360 video, browse through, find something, play that. It should just come out a lot better than what we're giving today. And one of the things that I also think we can improve on that experience is some of the stuff I've been experimenting with are more user controls inside video playback, where I always regret in just normal video players when you don't have things like frame advance and frame back. But in an immersive environment, it's almost a godlike power when you've got all the 360 stuff going on, you're like, freeze. Forward, 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 jog backwards smoothly, go forward. That's a really powerful feel, which plays to some of the strengths of virtual reality. So I've spent a lot of time in the last 6 months kind of leveling up my video skills in a lot of different ways, reading all sorts of ISO specs and writing implementations of different things. Now, I can't magically make a crummy 360 video look great. Although there is some interesting research opportunities and things going on with using machine learning to do things like super resolution, and frame rate interpolation is a reasonable thing to do. So there potentially is some room for magically make bad videos look better, but what I'm concentrating on is reducing the delta between what's actually captured and then what the user sees, because there are a lot of steps between that right now that do a whole lot of damage to it. So there's kind of 4 things that I'm working on that make a big difference on video. One, the simplest, most obvious thing that hardly takes any effort is just allowing users to take advantage of the bandwidth that they've got. We see Facebook does all of these surveys about how much bandwidth users have on average. And if you look across the main Facebook applications, you've got all these across the developing world, people that are on tiny little straws of bandwidth, and things that they do for videos. They have very low quality versions of things. One of the things that's really a shame right now that needs to be addressed is they have all the different levels of video quality, going from, in some cases, 4K down to these little 160 by 120 thumbnails. But there's a single audio track for anything that gets uploaded to Facebook with a single binaural, with stereo audio. The 360 audio is much higher quality. That's got a lot of bit rate. But if you just upload a big video, even if it's a 4K video and you upload it at 100 megabit per second master quality, the audio is coming down to 50 kilobits per second. And most people would say that even with good compression and everything, you should have 100 or maybe 150, depending on the codec that you're using. So audio takes a pretty big hit there. Again, changes in priorities. When all you've got likely is a little Gear VR speakerphone speaker, maybe that's not such a big deal. Now that we're focusing more on Go and everybody's got good, reasonable quality stereo audio, we can care more about that. So we look at the bandwidth rates, and lots of people on browsing the web or the Facebook application may have very low bandwidth, but the Gear VR users are way up there. They're people with premium smartphones that tend to have much better bandwidth. And the highest bandwidth version that you get from a video that goes up to Facebook is usually around 10 or 12 megabits per second. And that's somewhere around our median bandwidth for users. Like half of our users have significantly more bandwidth than that. So the easiest thing to do is say, well, let's just allow them to have a 20 megabit per second or some other higher rates there that let people that have the better bandwidth just magically get better pixels. So that can be a big help. The other thing is the newer phones. Since the Qualcomm S7 and all of the S8s, the codecs have the ability to decode 4K video at 60 frames per second. The earlier phones were limited to 4K at 30 frames per second, or the quirky aspect way back on the original Note 4, it could do 3840 by 1920 at 30, but 4K by 2K only at 24 frames per second. So encouraging more videos to take advantage of this greater headroom that we've got on the newer phones. Then one of the things that's bothered me since the very beginning, the original Note 4 releases, the frame release tempo on the videos has not been perfect, where I say 60 frames per second is magically so much better, but if you play a 60 frames per second video, it does not come out one-to-one video frame to display frame. And interestingly, this is something that got a lot worse, where on the original Note 4, there was a tiny tick of about 1 frame per second would get missed when we were using the Android media player. And I was heartened because I had noticed that, and the Felix and Paul people pointed that out. Hey, what's the deal with this little tick? And I was heartened to find that anybody else actually even noticed that. So that wasn't a huge deal, but I always thought, well, what needs to happen is instead of locking to the audio time, you need to lock to the video time and then slightly resample the audio rate. Because the videos are mastered at either 60 or 59.997 frames per second, but the cell phone displays have more variability than you'd think. There's 1 or 2% variability in the video frame rate, which means that you can wind up dropping a frame every second or two just to compensate for that. But if you instead match those 1-to-1 and resample the audio, then you can have it this perfect, every frame is a new one. If you don't resample the audio, then you find after 5 minutes that you've got this very long voice delay between what's going on the video and the audio. So I had wanted to do that for years. That had been on my on my hit list. I'd been trying to nudge other people to looking into doing that. But this year I finally sat down and said, all right, I'm going to address a lot of these video problems. Then the last on the pre-processing side is avoiding resampling in as many places as possible, where this was one of my keys to the super high quality text in VR Shell, where conventional VR rendering is a matter of rendering something to a flat 3D, rendering your 3D world to a projection, and then we distort the projection onto the screen to account for the lens distortion. So that involves an inevitable loss of quality. Even if you put the eye buffer up to an insanely high for mobile resolution, even if you ran it at like 1536 by 1536, even in the center there, you would wind up having a double resampling of the images. And of course, on the outside, you'd have aliasing. So shell is great because you draw to a flat image directly on your text instead of a random floating place in 3D world. And then that one gets resampled one time as it goes to the screen. Now, videos get resampled a lot of times in the process of kind of becoming the final pixels on your screen. It starts out that when you take a video on a camera, it's going to be saving it out in some compressed form. Whatever comes off the camera, hopefully it's at a very generous bit rate, but that gets pulled into a program to do some stitching with it, and then to eventually do whatever post-processing effects people go onto it. So it gets decompressed there, gets resampled into an eQuirect, and then saved out and delivered to Facebook or wherever it's going to be uploaded. Often there's multiple steps in between. Often it will be a matter of master at a high resolution, then resample that down to a lower resolution before going to Facebook. Then once it went to Facebook, we would resample it to a cube map of some kind. And this is a legacy of some early decisions that happened. And, speaking of early decisions, one of the things from 4 years ago that I still get to kick myself fairly regularly for, when I defined the cube map format, the cube strip format that we used for 360 photos, it's actually inverted. And we ran into this in Shell where, all right, we take photos inside Unity, or 360 shots inside Unity, they're like this, but all of our thousands of 360 photos that are already up there on the web served to 360 photos, they would all be like rotated and backwards, and worse for 3D videos, they would wind up eye swapped when you use the wrong one. So we have fix-up code dealing with this. But the reason we used cube maps initially was two things. One, everybody knows eQuirects waste a fair amount of data on the top and bottom. You've got these massive pole spreads, and it's about 30% more pixels that if you treat it as a cube map, you still have unequal distribution. The corners are much higher resolution than straight in front of you, but it's still about 30% better than eQuirects. And then the other aspect was being able to do the direct time warp sampling. Now, it turns out for videos, that hasn't been that huge, that important of a thing, because the direct sampling only really matters when your resolution is high enough that you're getting close to the resolution of your display screen. And we've always been a long way off in video resolution. But those were still the reasons that we did that. But the resampling means that you've probably noticed in 360 videos that sometimes you'll look one way and you'll see kind of a little stair-steppy artifact visible at the edges where things were resampled to this cube map. We should have been able to fix those by just slightly expanding our filter to overlap it a little bit. But the larger point is that every resampling does some damage in some way to the imagery. So turning it from an eQuirect into a cube map, even if in theory it covers the same number of pixels, you take your 4K cube map and you turn it into a 1280 by 1280 cube map that in theory even has more resolution in the cube map for most of the areas, but it's likely still going to be worse quality than if you had used the original one. And it's especially worse when compression is involved, because every step of these winds up getting compressed. So you H.264 compress this, and you get macro block artifacts of you've lost high-frequency components here, and you've got kind of a blurry block. Well, then you resample that, and you've got that blurry block that's now stretched across 4 blocks that gets recompressed. So you get multiple generations of compression artifacts kind of baked into it. The ideal world would be if you took something from a camera, and the direct raw images from the camera were then projected appropriately into virtual reality. And it's possible to get what I've been chasing with video quality for years now is display limited resolution, where we have some media, like our 360 photos, that are at a higher resolution in some areas of the screen than what the physical display, the 2560 by 1440 display on the devices is. And some of these, like the best 360 photos made by the photographers that really know what they're doing and have done everything right, and certainly the synthetic ones, like all the Otoy render the metaverse images, these are still the finest looking things that you see looking through a headset. And for years, I've been, if only we could make these move, if we could have this quality of pixels and in our videos, that would be a really magical thing. It would be very different than what we've got now. And just a few weeks ago, I started doing some tests. There's all the ways that we've chased this. We had the view-dependent streaming was our big bet that we thought was going to allow us to get display-limited pixel quality in the middle. And the way that would happen is content creators could upload a 6K video, like a 6K by 3K video, and then we made 20 different versions of this, depending on exactly where you were looking. But it really did turn out kind of disappointing in that you'd be looking here, and if you sat there and you only looked straight forward and you got to the right quality level and everything, there were a number of things that had to happen to turn out right. But sometimes it looked really great. You had extremely high quality. But what almost everybody would notice about it is, well, that's interesting. I look over here, and now it looks like garbage over here for 2 seconds until it winds up picking up that stream and streaming that in, and then it snaps into a super high quality. And that was very much a mixed bag, and I think most people decided that it was a net negative. And this is something that we could A/B a lot in terms of how many people watch longer videos if we turn that off and just give them the cube corner, like our best other projection, versus that. And the truth was, people would give up watching those because there would be more hitches in the display and the differences in the video quality. So that was not going to kind of give us this magical quality level. But something that came up just a few weeks ago, Matt Hooper had been working on the idea of like, well, what are we going to do for our in-store demos for selling Oculus Go's? There's questions of, do we just have an app launcher? Do we have some kind of intro to VR video? What do we want to do? Well, we really want to make the best possible quality that we can put. We want to put our best foot forward there, get the highest quality videos and different things that we can mix in some 3D environments. But we started talking again about my quest for this display-limited resolution. And we were saying, well, if we wanted to just do an experiment about what could this look like if we just, everybody knows now that if you go from a 360 to a 180 video, you double your pixel quality, and that's a pretty big step. And it's like, well, what if you drew it in even more? There would be some point at which you would be at the display-limited resolution. And by kind of a happy coincidence, it turns out that just regular GoPros, one of their resolutions where you're at 1920 by 1440, that's at a 90 degree by 120 degree field of view. That is almost spot on to what Gear VR's actual resolution is. So, Matt went and set up a couple GoPros, did the type of thing that probably dozens of you in the audience have gone and done, set up a stereo camera rig, worked out the syncing stuff, and started taking some footage with that. And I played this with all my latest code. I call the new suite, there's Video Direct for the playback part of it, and then I've got Dash Direct for the streaming and Multi-Streamer for doing multi-socket streaming, all these different things. So I plugged it in with the Video Direct backend, and it looks pretty amazingly good. I experimented with a few different edge treatments. There's like a 3D model around the edges, or a properly positioned 3D fade, or just showing the raw camera edges. And I've been showing a bunch of people around here. In fact, like 1 minute before they pushed me out onto the stage here, I was showing one of the producers that did all of the kind of stage production work here. Now, this is what our video should look like. This is what's possible. And it gets an amazing reaction. And probably 20 or 30 people have gotten my S7 passed around to see this while I'm here, and I'm here certainly the rest of the day, and more people will see it. And I'm looking at this as this is very much like what I did last year, and if I can keep this going in future years, this will be great. Show how text and imagery should look last year, deliver VR shell, show how video should look here, and deliver massive video improvements next year. But it reinforces to me that there is magic there, that there's something very powerful. Getting locked stereo, locked 60 frames per second, having everything work perfect without the glitches, without the artifacts at that resolution, it's really a pretty big deal. And these were just GoPros, where professional lenses, professional lighting, you could stretch out the fields of view. Even if you weren't doing any more tricks, you could go to, that's not maxing out the codec resolution. You could go to maybe 160 by 120 or something and still have this exact same super quality. To go beyond that, we start looking at many more kind of tricks and games. We can do more projections if we don't mind a resampling on the way. I have some some hardcore H.264 bitstream hacking stuff that I want to do for people that have location-based things that don't care about maybe loading up gigs of video if I can rebuild synthetic bitstreams on the way. So there's possibilities there. But again, put all of these things together, avoid resampling, use the bandwidth people have available, take better use of it using multiple socket streaming, so on. And the way I'm doing all of this is for this narrow path. We use Exoplayer for most of our, almost all of our video work. It's great software, open source from Google. Most of our video stuff is based around this. But it's a big Java application that doesn't specifically cater for the like the super high-res videos and things that we're doing. So for this narrow path, I have custom code that my goal was to own it from kernel sockets to media codec layers and everything in between, not having anybody else's code. So for the specific cases, I can wrap all of this stuff together and have a much, much better quality presentation. We are piecemeal putting some of this into the rest of the systems where the video direct kind of backend, the video team has replaced Exoplayer's general backend. So a lot of things get some advantage from this, but they don't get the frame locking and resampling, and then they're not using the multi-streamer side of things, lots of other stuff there. So we're going to have tiers of different things, but the most important thing is that in the not too distant future here, side-loaded MP4 videos, if it's in MP4 and it's a local file, playback will get a lot better for 4K 60 for these very demanding things. Instead of copying through an intermediate buffer, it's directly rendering it. It's very power efficient as well as being very, very frame locked. You can play a 4K 60 video for something like 3+ hours sitting there on like on an S7 class system. So there's interesting possibilities there as opposed to trying to play 4K 60 video. Right now, it's got this terrible tempo judder problems where it'll be smooth. If you watch like the great Felix and Paul stuff, we've got Emmy Award-winning videos, and I look at that, and it plays smooth and goes stutter, 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 smooth, stutter, stutter, stutter. And like they're saying like typographers can say if you hate someone, teach them to recognize bad kerning. How the letters aren't necessarily spaced correctly together. Well, I want to teach everyone to recognize bad video frame release tempo. When you're looking at videos and you're watching something moving smoothly, and then it glitches a frame, and then it goes on. When we were running the main keynote, and we have all this animation, I'm critically looking at this going, all right, they've got the frames right. They're not dropping frames. When I was at GDC earlier this year, they had a similar super expensive high-end video projection system, and they had the same damn tempo release problem. Animations going on, smooth, stutter, 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 smooth. Usually it's like smooth and then a little glitch as you're going from 59 to 60, but there's a problem when you've got asynchronous time bases where you fall into this smooth and then stutter, and the graphs look absolutely terrible from it. But there's good quality to be had from this. On the content creation side, there have been a lot of interesting learnings and surprises as we look at the data, and as part of Facebook, and we've got a great kind of analytics team on some of this, there are some interesting insights that you get from really paying attention to what people are actually doing. Some of the stuff that people never would have guessed 4 years ago, things like roller coasters are unreasonably effective with people. I mean, it is shocking. Not only do people watch the roller coaster videos, they go back and watch them again and again. They're some of the most replayed things, which violates all of the basic wisdom about like what a good VR experience should be, focusing on comfort, not doing the locomotion, not turning in parabolic arcs and different things. But, the honest truth is people are doing them. They'll watch them, and then they probably go around and they show their friends and all these other things. Another one is horror genre, where that makes sense in hindsight that putting someone in an immersive virtual environment cut off from the world, that what makes horror tick as a genre can be much more effective there. And horror has never really been my genre, but I recognize the effectiveness of this in many cases. I know like most of the Face Your Fears was fine, but the creepy bedroom scene on there, I'm like, I just don't want to see the rest of this. It's impactful enough there for what it's trying to do that it has a powerful effect. And a lot of our videos, just in 360 videos, are similarly very high ranked with horror genre. some of the stuff that comes down to kind of brass tacks on development, where the dramatic stuff is often very popular. The Lego things are always very high on our rankings, the Lego Batman and so on, Lego Star Wars now. But it's very expensive to produce those, high quality 3D rendering. But things that are also often very popular that are dirt cheap to produce are things like the animal videos. Nature videos, somewhat less so, but then putting actual animals in there and letting them come up right around the camera. It's basically cat videos sort of thing, and that is also remarkably popular in VR. One of the things that Google announced that I thought was really important, and I'm kind of disappointed that I haven't seen more aggressive follow-up on this, because I thought it was potentially one of the really great ideas here, was pushing more on the 180 videos and allowing it to, if we can convince people that do normal things like on YouTube or whatever, if instead of just having the one camera pointing at them, you put a dual 180 stereo camera, but you automatically pull out the appropriate 1280 by 720 center part to send to everybody that's watching it normally, that becomes something that you serve all of the existing customers, but then, please stop flashing the go to QA, I'll get it in a minute. But then you get this wonderful immersive experience that really is different. And if you, especially at 4K 60, it is at that distance, when you're just like 3 feet away from people with good quality, it is a magically different experience. And I think that's an opportunity to get immense amounts of content. And that seemed really brilliant at the idea, and I think they did a few trials with that, but I hope that rolls out really broadly, because almost everything that people wind up doing, cinematography or videography-wise, we have all these things that we know how to do, pointing the camera at it. And some of the things that wind up being surprising, talking about people that go through the work of 360 production, is that you think about like all the challenges about, okay, obviously you can't have your set stuff back here, but you can't have your director sitting behind the cameras, which is something that directors are used to being able to do and kind of direct the action in various ways. And there are all of these challenges with 360 where there are certain things that 360 is better than anything for. When you put yourself in some wonderful environment and you look around, you appreciate the whole thing. But it really does seem likely that that is a subset of the things that people want to experience. And we also find that, unfortunately, people don't turn around nearly as much as we kind of wish they would. For years, I preached the virtues of swivel chair gaming for Gear VR, that this is, the way to have the most fun in a gaming experience is to either stand or sit in a swivel chair and be able to turn around 360 degrees, chase the action wherever it's going. And I think the best games are still like that, but the vast majority of people want to sit on their couch and have something happening in front of them. So I think that there's an excellent opportunity for taking things that you're going to present normally in a rectilinear format, but then also producing for free, essentially, a high-quality immersive version of it that you can get with almost no extra work. Because production costs matter. We start looking at these and say, all right, it's great that we won an Emmy for The People's House, but that was really expensive to do. Everybody can't build content like that, and YouTube has certainly shown that a lot of surprisingly low-budget, inexpensive content winds up being extremely powerful for people and makes a big impact.